Hi guys, Miss Co here. It's conditional probability homework, 9C problem number 2 on your homework. So this one is conditional probability using a table, okay? Using a table. So let's go ahead and just jump into this problem. Number 2 says a department store employs 28 high school students, all juniors and seniors. 6 of the 12 seniors are female. So we have categories here on your table for juniors and seniors, and then also male and female. So there's 12 seniors that are female and 12 of the 16 juniors that are male. One student employee is chosen at random, okay? So our first part of our problem is part A, and it wants to know what's the probability of being a senior, and what's the symbol here, okay? That's the or symbol, right? The or symbol. I don't know why I did that backward. So or symbol, okay? And when we do or, what we're saying is, hey, let's just look at our Venn diagram and just kind of remember what or is, okay? So if we had 2 different kinds of categories, right? Well, you can be A, or you can be B, or you can be both A and B. So a bigger category, right? Or is a bigger category. So the probability of being senior or female, we're going to first look at being a senior. Well, there's 12 seniors here. The senior males, there's 6 of them. The senior female, there are 6 of them, right? So we know we for sure have 12 in that senior or female, okay? But we also have a female category too. Now, we don't want to just add the 10 and the 12. That doesn't work, okay? Because if we added the 10 and the 12, that's adding that 6 twice. We don't want to do that. So instead of doing it that way, we're just going to add the female part that we haven't already added, okay? So we'll add that 4. That means that the total number in the senior or female category is 16. And the probability in this whole category, the total number of possible outcomes, that's 28. Okay? So now we're going to look at part B. And I'm going to erase these guys for you. But here's that answer on A. 16 out of 28. Okay? So for part B, let's look at part B now. Junior, and what's the symbol? That's the and symbol. And remember, when we're looking at a Venn diagram, the and means that category has to be A and it has to be B as well. It has to qualify for, they have to be a junior and they have to be male. Okay, so if this is our junior category, this is our male category, they have to be both. They have to be junior and they have to be male. So that's a limiting term in probability. And means they have to qualify in both categories. Okay, so what's the probability of being junior and being male? So when we look at it on our chart, we're looking at a junior and male, that's our 12. So the probability of being junior and male, that's 12 over 28. All right, part C on problem number 2 asks, what's the probability of being male? Probability of being male in our sample set. So the total number of male in our sample set, that's 18. That's over here. And then the total possible outcomes in our sample set is that 28. Okay. What about being a senior? What about being a senior? Well, there are 12 total seniors. Okay. So we have our specified outcome is senior. Our total possible outcomes, that's our 28. Okay. So that's the probability of being a senior. 12 out of 28. Okay. And that doesn't look great. Let me just do that a little better for you guys. I'm trying to write it the way that you guys can type it. on your keyboard so you can kind of see how to look on your test. All right, part E is where we start with conditionals. So on this problem on part E, we're looking at a condition of being female. This second part after the line, we have a line and then we have some kind of stated condition. So our condition is that we're only looking at females, okay? So what that means is that when we're looking at our data, we're only looking at data that's in the female category. Everything else is covered up, right? We're only looking at this data right here. Everything else we're covering up. We're ignoring, okay? So we're just going to look at the female data, okay? Now, it's particularly wanting to know all this is gone. We're going to ignore it, okay? So what we're interested in is what's the probability? What's the probability of being a senior? Well, it's conditioned on being female, right? So we're only going to look at that 6. The total number of seniors in that female category is 6. The total number altogether in that female category is 10. So that's our answer. Now, you can simplify this fraction like all of the other ones. Okay, that's 3/5, right? You can do it in decimals, but I'm also allowing you guys to just leave it in that original fraction, okay? So I'm going to move on to part F. Okay, so senior female, we're saying is 6/10. All right, so for part F, we're looking at another conditional statement, but this time is conditioned on being a junior. Okay, so we're only looking at information in the junior category. So this time the category we're looking at, we're just looking at this data, nothing else, okay? Just looking at that junior data. For a total number of males, again, just in that junior data, is 12. That's how many junior males we have, okay? So we have 12 junior male. The total number in that category, our total possible outcomes, given that they're a junior, is 16. Okay? So really easy, guys. Not a hard one. This part G, we're looking at the condition of being a senior. Okay? So again, we're just looking at our senior data, nothing else. We're ignoring everything else. The total number of females we have that are in the senior category is 6. Okay? And the total number in that category, the total number of outcomes in that senior category is 12. Okay? So guys, our last one is we're looking at the probability of being senior, but conditioned on being male. So again, we're just looking at the data in that conditional category. Okay? So in that conditional category, we're only looking at data in that male category, nothing else. Just looking at data in the male category. Our total number of seniors in the male category is 6. The total number in the male category is 18. Okay? So that's how you do problem number 2 of the 9C homework. Thanks, guys.